Hello everyone. Welcome to the solution of LeeCode problem 58 named length of last word. In this problem, we are given a string as consisting of word and spaces, and we have to return the length of the last word presented in this string. The definition of the word is a word is a maximum substring consisting of non-space character only. Now let's understand the first example. The current string is hello world, and the length of the last word, which is 5. Here, the last word is world, W-O-R-L-D. It has 5 characters, so the length is 5. So in this case, we have to return 5. In the second case, there are some leading spaces and some trailing spaces. And the string is fly me to the moon. Here, the last word is moon, which has 4 characters. So in this case, we have to return 4. Again, in the third example, the given string is Luffy is still joy boy. Here, the last word is joy boy, which has 6 characters. So in this case, we have to return 6. I hope you understood the problem. Now let's move on to the constraint. Here, the length of the string S can be in between 1 to 10 to the power 4. And S consists of only English letters and spaces. And there will be at least one word in the given string, which is mentioned. I hope you understood the constraint. Now let's move on to the solution. Here, the solution is very simple. We have taken the second example here, which is fly me to the moon, which has some leading zeros and some trailing zeros. And considering these leading and trailing zeros, we have to calculate the length of the last word, which is moon. Here, in this case, the output will be 4 because moon has only 4 characters. So how can you do that? We can do that using a simple method, which is string stream. This is a built-in STL in C++. String stream is very simple. Basically, it parse the entire string and extract each of the individual word from this string. Suppose if we perform the string stream into this whole string, the first word is fly. We will separate it here. The second word is me. We can separate it here. The third word is to. We can separate it here. The fourth word is the. We can separate it here. And the fifth word is moon, which is separated here. And it has 4 characters, 1, 2, 3, and 4. Now, suppose this is a container, or we can say that this is a vector which holds the word extracted from the string by using the string stream function. Now, it is very simple. From this vector, we can easily extract the last word by using the back function of C++, and we can simply print the size of this last word. And that's how we can use the string stream function. I hope you understood the logical part. Now let's move on to the code. And if you understand the code, I hope everything might be clear. Here, the code is pretty simple. At first, we are given a function, length of last word. The return type of this function is integer, and the parameter of this function is a string. Now, we are taking a string variable, which is word, and here we are using string stream. This is the syntax of the C++ string stream method. And for storing the word, we are taking a vector. The name of this vector is VC. And by using this while loop, we can extract all of the word, excluding the leading and trailing zeros from the string, and store them into the resultant vector. And if our current string does not contain any word, in this case, we have to return 0. Otherwise, we have to simply extract the last word by using the back function and simply print the size. I hope you understood the code. Now let's move on to the time and space complexity of this program. In this program, the time complexity is big O of n, where n is the length of the input string. This complexity arises from the process of splitting the string into words and storing them into the vector. Apparently, the space complexity is also big O of n, where n is the length of the input string. The space complexity arises from the space used by the vector VC to store the words extracted from the string. Additionally, the word variable also contribute to the space complexity, but its impact is minimal compared to the vector when the string is large. So we can say that the space complexity is big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.